Welcome to example 4. In this case, we have a CD that is rotating from rest to an angular velocity of negative 31.4 in a time of 0.892 seconds. And we're asked to find the angular acceleration, the angle that it rotates to get up to that speed. We're told the radius of it is 4.45 centimeters, and we have to calculate, of course, the linear velocity and also the tangential acceleration. So let's start off by writing what we know as the knowns. So we have it's starting from rest. That means the initial angular velocity is 0. It does reach a final angular velocity of negative 31.4 rads per second. So hopefully you understand that negative is just implying that it's going in the clockwise direction. The time is 0.892 seconds. And we'll write down the radius here is 4.45 centimeters. So in part A, let's go ahead and solve that. That is asking for the angular acceleration alpha. Right? So the solution here for part A, we use the kinematics equation. Angular velocity final is equal to the initial angular velocity plus the angular acceleration multiplied by time. So we have a negative 31.4 equals 0 plus alpha times 0.892 seconds. This gives me an angular acceleration of negative 32 rads per second squared. It's like negative 31.97556, so I'll just round up to negative 32. Okay, moving on to part B. The angle that is needed to reach up to that speed. How much angle does it pass through? So we'll assume that the initial angle is 0 here. And there's a couple ways to do that. You could use omega squared equals omega naught squared plus 2 alpha and then find delta theta. You could also use theta equals theta naught plus omega naught t plus 1/2 alpha t squared, whatever your preference is. Okay, I'm going to maybe just go with the first one. So we have negative 31.4 squared, 0, so this whole term goes to 0. Okay, we have 2, and then we have calculated alpha, negative 32, and delta theta. So delta theta will be equal to an angle of negative 15.4 rads. Okay, now we move on to part C. Let's find the tangential speed. And I do realize there's a little typo here. I think this should be just negative 32. Okay. Part C is asking for, we got B, which is the change in the angle. Part C is asking for the linear velocity. So part C is a very nice, easy equation. V equals R times omega. So we just plug in R. Now R, since we want to answer in meters per second, we're going to put that into meters. So that's 0.045 meters. Multiplied by our angular velocity at that point, which is negative 31.4 rads per second. So this gives you a velocity of 1.413. I'm not sure why I wrote 1.40, but I believe I did that correct. 0.0445. Yeah. Oh, I know why. There should be a 4 in here. All right, so actually that makes this 1.3973, so 1.40. So this answer is correct. Okay, moving on to part D, which is the tangential acceleration. And to do our tangential acceleration, I'll just do the solution here. D, we just use a similar equation that we did for the velocity. The tangential acceleration is really the radius multiplied by the angular acceleration. So the radius is again 0.0445 multiplied by the angular acceleration, which we calculated as negative 32. This will give us a tangential acceleration of negative 1.566, well, 1.57 meters per second squared. Okay, and that's it for this example.